Well, ahoy there, mateys. We are going to jump right into 7.2. It's all about solving equations using addition and subtraction. But first, we must review how to plug and chug, I like to call it. So you're basically substituting and evaluating the expression. So hopefully you remember how to do this from 7.1. I know it's been a little while. So what is, for number one, what is 3 plus x when x equals 2? It is 5, yes. Well done. All right. What is a plus 16 when a equals 4? Yeah, you replace the 4 here, and 4 plus 16 is 20. All right, what about 10 plus z when z equals 5? It is 15. Nicely done. 10 plus 5 is 15. What about 17 minus c when c equals 9? Yes, 17 minus 9 is 8. What about 8 minus w when w equals 8? If you said 0, you're right. All right, and the last one, s minus 20 when s equals 34. Yeah, 34 minus 20 is 14. So that was step 1 in solving equations. Because when you solve equations, what you're trying to do is figure out what value for our variable can we plug in to make it true. So an equation now has an equal sign. So like here we have p plus 10 equals 38. So there's a number for p that makes that true. And what this one wants you to do is basically to say true or false. If p equals 18, is that true? So is this a solution? So is p equal 18 a solution to p plus 10 equals 38? No, it's not. When you replace p with 18, 18 plus 10 is 28, not 38. Therefore, it is not a solution. What about the second one where 4y equals 56? Is 14 a solution? Well, let's plug it in. 4y means 4 times y, 4 times 14. Oh, look, that is 56. So yeah, 14, y equals 14 is a solution to 4y equals 56. Okay, you're going to be using this to check your answers when you solve them. This is not how we're going to solve, though. We're not going to guess until we find the right number that works. There's better ways to solve it. And notice they have these little scales here, these little balances. That's what we're going to talk about next. So basically what an equation is, when you have an equal sign, you have a balance. Woo! And this side here equals this side here. They're in balance, in harmony, as it should be. So here we got a red ball and 2 blue blocks, and you have them on both sides, which means they are balanced. So if you were to remove a red ball from this side, you also have to remove a red ball from this side, and then it stays balanced. If you wanted to, you could remove a block from each side, and it's still balanced. You can also add things. As long as you're adding the same thing to each side, it remains balanced. That's true for equations. So here, let's say we're solving n plus 3 equals 7. The n, that's our red ball. We have to figure out how many blue blocks does that red ball weigh. Okay, so you can model it with n, that's our red ball, plus 3 blocks, equals 7 blocks. Now they are balanced. One way to solve this is you remove the 3 blue blocks and you're just left with the red ball. But if you remove 3 blocks here, you also remove 3 blocks here, and then hopefully you can visualize that this red ball must equal 4 or 4 blue blocks in this case. Okay, so that's how much a red ball weighs. So what you're doing basically is you're trying to get the variable all by itself. Now, for 7.2, all of this will be done with addition and subtraction. You're going to do what's called the inverse operation. So if the problem itself, like here, we had addition, you subtract to solve. Okay, let's jump in and try one of these. So number 1, n plus 9 equals 12. So this is an addition problem. So what are we going to have to do in order to solve it? Yeah, we're going to have to subtract. So you'd subtract 9 on each side of this equal sign. That'll make this 9 go away, and you'll just be left with n here. 12 minus 9 is 3, n equals 3. Now to check that, you'd plug 3 in here. 3 plus 9 is indeed 12. Yay, it works. Okay, for number 2, we have r plus 4 equals 8. So you're going to have to subtract to get the answer. So what is the answer for number 2? Yeah, it's 4. So if you subtract 4 here, subtract 4 from the 8, and you get r equals 4. Okay, here, p plus 1 equals 4. What's the answer for p? It is 3. So when you subtract 1 on each side, you end up with p equals 3. Okay, for number 4, what are we going to have to do to solve number 4? Yes, because it's a subtraction problem, we need to add to solve it. So you're going to add 2 to each side, and you're going to end up with t equals 6. So when you add 2 here, this minus 2 will go away, and this 4 becomes 6. So t equals 6. You can check it. 6 minus 2 does equal 4. It works. Okay, solve number 5. What do you get for number 5? Okay, so hopefully you added 5 to each side, and you end up, this 5 will go away here, and you end up with 7 as your answer. D equals 7. Again, you can check it. 7 minus 5 does equal 2. And this last one, x minus 3 equals 1. Solve that. Okay, hopefully you said 4. You add 3 to each side, because this is subtraction. You do the inverse. And when you add 1 plus 3, you get 4. Boom, and you can check it. 4 minus 3 equals 1. Fantastic. If this was easy, I think you're going to like today's assignment. If this was a little difficult, well, we're going to practice a little more anyway. All right, so try to solve this one. X minus 2 equals 6. All right, so we've written our expression out. You're going to add 2 by undoing the subtraction. That's the inverse operation. That leaves you with x on this side. These 2's are gone, and 6 plus 2 is 8. Okay, now you should always check your answer. Let's see if they did it. Oh, they did. It's here. Whee! So yeah, you should check your answer once you get it, and basically you check it by plugging it back into this original equation. So 8 minus 2 equals 6. Yes, it does. We're right. All right, try to solve this one. 18 equals x minus 7. All right, so hopefully you added 7 to each side, and you get 25 equals x. That's the same as saying x equals 25. So x is 25. Again, you should check it by replacing 25 here in the original equation. So we get 18 equals 25 minus 7. Oh, yes. Yes, it does. It works. Hey, fantastic. Okay. And we got a couple more to practice here. So solve this one. X plus 2 equals 9. Yeah, subtract 2 on each side, and you end up getting x equals 7. Which, again, let me move myself because we're going to put the check answer here. You plug it back in to check it. 7 plus 2 does equal 9. It is correct. And the last one, 26 equals 11 plus x. Solve that one. Okay, this one, you subtract 11 on each side. You end up with 15 equals x. You can check it. 11 plus 15 does indeed equal 26. It is correct. Okay, it's very important that you don't guess the answer in your head to make sure it works, because although these are small and easy to do in your head, soon we're going to get to fractions, decimals, and big numbers and negative numbers. You don't want to have to guess the number in your head. You want to have a method to solve it. This inverse method always works. Okay, and the last one we're going to do is a word problem. Your parents give you $20 to help you buy a new pair of shoes. These yellow, lovely shoes that are 59 something, it's blurry. After you buy the shoes, you have $5.50 left. Write and solve an equation to find out how much money you had before your parents gave you $20. All right, so let's just walk through this one, and then I'll have you solve it a bit. So we have the starting amount plus the amount your parents give you minus the cost of the shoes is how much you have left. So just absorb that for a second. All right, so S or X or whatever variable you want to use is going to be our starting amount. So here we got S plus 20, that's how much they gave you, minus the $59.95, that's this blurry price right here, equals $5.50. So now what I want you to do is figure out what S is. Whatever method you need to use, figure out what S is. All right, now let's walk through how to do it. So hopefully you were able to, the way they solved it is they got rid of this minus $59.95 by adding $59.95 on each side. That'll get rid of it over here. So now you got S plus 20 equals $65.45. And then you can subtract 20 on each side to get that S equals $45.45. So if that's what you said, then you got it. That's about as difficult as anything you're going to see as you work through Big Ideas 7.2. If you need any help, send me an email, send me a Flipgrid, see Mrs. Rude in the ASC, or ask me questions during class, and I'll see you in the next live session. Arr!